Lesson: avoiding bias in AI systems. Avoiding bias in AI systems is a crucial component of ethical AI development and deployment. As AI technologies pervade various aspects of society, the potential for biased outcomes poses significant ethical, legal, and social challenges. Bias in AI can arise from numerous sources, including biased training data, algorithmic design choices, and systemic issues within institutions deploying AI systems. Addressing these challenges requires a multifaceted approach involving actionable insights, practical tools, and frameworks that professionals can implement directly. One of the primary sources of bias in AI systems is biased training data. AI models learn from historical data, which can contain biases reflecting societal inequalities or prejudices. To mitigate this, professionals must first understand and identify potential sources of bias within their datasets. This can be accomplished through data auditing, which involves examining datasets for uneven representations of different demographic groups or exclusion of certain groups altogether. For instance, a study might find that an AI model trained to predict recidivism rates in the criminal justice system is biased because the dataset overrepresents certain racial groups. Once potential biases are identified, a practical tool to address them is the use of data augmentation techniques. These techniques involve adding, removing, or modifying data to balance demographic representations and reduce potential biases. For example, if an AI system is being trained to recognize faces, data augmentation can be employed to ensure diverse representation across different ethnicities and genders. This approach not only improves the system's fairness, but also enhances its overall performance by exposing it to a wider range of variability. Algorithmic bias is another significant concern, as the design and implementation of algorithms can inadvertently introduce or amplify biases. To counteract this, one effective framework is the use of fairness constraints during model training. Fairness constraints involve incorporating ethical considerations directly into the optimization process of machine learning models. For example, a fairness constraint might ensure that an AI system's predictive performance is equally accurate across different demographic groups. This approach can be applied in various contexts, such as hiring algorithms, where fairness constraints ensure that candidates are evaluated without gender or racial bias. Moreover, explainability and transparency are essential tools for professionals seeking to avoid bias in AI systems. Explainable AI techniques provide insights into how AI models make decisions, enabling the identification of potential biases and fostering trust among users. Techniques such as local interpretable model agnostic explanations and Shapley additive explanations allow practitioners to understand and visualize model predictions, thereby facilitating the detection and correction of biased outcomes. By making AI systems more transparent and interpretable, professionals can identify and address bias more effectively. A critical component of avoiding bias in AI systems is the establishment of governance frameworks. These frameworks guide the ethical development and deployment of AI technologies within organizations. One example is the IEEE Global Initiative on Ethics of Autonomous and Intelligent Systems, which provides comprehensive guidelines and standards for ethical AI practices. By adopting such frameworks, organizations can ensure that ethical considerations, including bias mitigation, are integrated into every stage of the AI lifecycle, from design to deployment and monitoring. In addition to these technical and organizational strategies, professionals must engage in ongoing education and awareness-building efforts. Bias in AI is a complex and evolving issue, and staying informed about the latest research, tools, and best practices is essential. Participating in workshops, attending conferences, and collaborating with interdisciplinary teams can enhance professionals' understanding of bias and its implications. For instance, the Partnership on AI, a collaboration between academia, industry, and civil society, offers resources and events focused on advancing ethical AI practices and addressing bias. Case studies provide valuable insights into the real-world challenges of avoiding bias in AI systems and the effectiveness of various strategies. One notable example is the case of Compass, a risk assessment tool used in the criminal justice system. Studies revealed that Compass exhibited racial bias, disproportionately predicting higher recidivism risk for African American defendants compared to their white counterparts. In response, researchers and practitioners have explored alternative methods, such as using more transparent and interpretable models, to mitigate bias and improve fairness in criminal justice AI applications. Another case study involves gender bias in natural language processing models. Research has shown that NLP models can perpetuate gender stereotypes by associating certain professions or adjectives with specific genders. To address this issue, researchers have developed debiasing techniques that modify word embeddings, which are the underlying representations of words used by NLP models. These techniques involve identifying and removing gender-specific components in word embeddings, thereby reducing gender biases in language models. Such efforts demonstrate the potential of technical interventions to reduce bias and promote fairness in AI systems. Ultimately, avoiding bias in AI systems requires a holistic approach that combines technical, organizational, and educational strategies. By leveraging practical tools such as data augmentation and fairness constraints, implementing governance frameworks, and fostering a culture of transparency and explainability, professionals can create AI systems that are more equitable and trustworthy. Moreover, ongoing education and collaboration within the AI community are essential to staying informed about emerging challenges and solutions related to bias. In conclusion, the avoidance of bias in AI systems is a complex but essential pursuit in the realm of ethical AI. Through the use of innovative tools, frameworks, and strategies, professionals can address the multifaceted nature of bias and work towards the development of AI systems that uphold principles of fairness and equity. By learning from case studies and real-world applications, practitioners can gain insights into the practical challenges and successes of bias mitigation efforts. As AI continues to shape our world, a commitment to ethical principles and the avoidance of bias will be paramount in ensuring that AI technologies serve the betterment of society.